Welcome everyone. So in this video, we're going to talk about limits involving plus or minus infinity. Let's take a look at those problems and see how to approach them. So these are the 5 problems I'll be working out in this video. Feel free to pause, work it out on your own, and then you can check your answers with mine. So let's start off with this one right here. Let's call this number 1. For that problem, we want to find the limit as x approaches infinity of the square root of 8x squared minus 3x over 2x squared plus x. So by limit laws, I can simply take the square root outside the limit, and we get the limit of, as x approaches infinity, 8x squared minus 3x over 2x squared plus x. So I can do that by applying limit laws. Well, the idea with infinity or plus negative infinity is to divide top and bottom of the function by the highest power of x in the denominator. For this problem, the highest power happens to be this one right here. So I'm going to go ahead and take every term from top and bottom and divide by x squared. So let's go ahead and do that. So if we do that, we have the square root of the limit as x approaches infinity. So 8x squared divided by x squared minus 3 over x squared all over 2x squared over x squared plus x over x squared. And once I have done that, I will simply simplify. So this is equal to the square root of the limit as x approaches infinity. So 8x squared over x squared, that's simply 8. And 3 over x squared, that doesn't simplify. And 2x squared over x squared, that's 2 plus 1 over x squared. Now let's take the limit. So this is equal to the square root of, by limit laws, we can write this as limit as x approaches infinity of 8 minus the limit as x approaches infinity of 3 over x squared. So I'm showing more steps, but you can do all of this mentally. Then we have the limit as x approaches infinity of 2 plus the limit as x approaches infinity of 1 over x. Now analyze these limits. Well, we know this limit of a constant, is just a constant. Then this limit, as you put large values for x, overall 3 over x squared will go to 0. So we can say that this limit is 0. Similarly, this limit right here, so this one right here, this will also go to 0 as you plug in large values for x, because 1 over x will be very small. So this is also 0. And of course, this is the limit of a constant. It's just that constant itself. So overall, what we have is the square root of limit as x approaches infinity of 8, that's 8, and limit as x approaches infinity of 2, that's 2. So this simplifies to simply square root of 4, which is 2. So the limit of this function is 2. Okay, so hopefully this is making sense. Let's go ahead and try our second problem. So the second problem we're going to do is this one right here. So I'm just going to pull it downstairs so I don't have to recopy the question. So put it right here. And now let's work out this one. Similarly, we have everything to the 5th power. By limit laws, I can pull that outside the limit. So you have the limit as x approaches negative infinity, 1 minus x cubed over x squared plus 7x, everything to the 5th power. So that's by limit laws. And now we do the same thing as before. We divide everything by the highest power of x in the denominator. That's this one right here. So let's go ahead and do that. So this is equal to the limit as x approaches negative infinity, 1 over x squared minus, and then x cubed over x squared. So you know this will simplify to just x. So this would be x all over. On the bottom, x squared over x squared, that's 1. And then if you have 7x, you divide that by x squared, you get 7 over x. So I'm going to replace it right here. And now we're ready to take the limit, all of this to the fifth power. So now by limit law, if you push the limit inside, this will go to 0 and this will go to 0 because x's are in the denominator. So the only expressions we're left with are this one and this one. So we have negative x over 1. If you take the limit by simply plugging in negative numbers, so let's say negative 10, negative 100, negative 400, and you'll see that that's a negative times x over 1, which will be a positive value. So we can say that that's plus infinity. So this limit is actually positive infinity. Now let's go ahead and take a look at the third example we have. So the third example is this one. So I will go ahead and copy this on the bottom. There you go. So we'll do the same thing. We'll take the highest power of x in the denominator and divide everything by that. So the highest power in this problem happens to be x. So let's go ahead and simplify. So we have the limit as x approaches infinity of 2 square root of x over x minus. Now, if you want, you can rewrite this as 1 over x. Yeah, let's do that. Why not? And then I'm dividing that by x. So that's the same thing as multiplying it right here. All over 3x over x minus 7 over x. Once I have done that, I will simplify this. So this is simply the limit as x approaches infinity. And if you simplify this one by laws of exponent, the square root of x is x to the 1/2. So you have 1/2 minus 1, which will simply be 2 over square root of x minus 1 over x squared all over 3 minus 7 over x. And now we're ready to take the limit. So this would give us, if you plug in infinity for this one, try to approach a large number. This will go to 0. This will also go to 0. This will also go to 0. So all of these will go to 0 as we approach infinity. So what we're left with is 0 over 3, which is simply 0. So this limit is 0. So I hope this is making sense. So here's the next problem. We want to find the limit of this. Now it looks like these terms are very confusing. You have negative 1 power here, negative 4, negative 3, negative 2, negative 3. You want to make them positive and then try to approach by the rule we mentioned earlier. So algebraically, I can rewrite this function so that it looks simplified to my eyes. So this one right here, that's same as 1 over x. So you can write it as 1 over x plus, and then this right here, that's x to the negative 4th, which is same as 1 over x to the 4th. All over, do the same thing for this one and that one. So they're all written in positive exponent like that. So it's a minus sign at the bottom, 1 over x cubed. Now, algebraically, you want to simplify this before you apply the limit rules. So the highest power on the denominator, well, before I do that, what I want to do is I want to simplify it. So I think I'm going to go ahead and multiply everywhere by x to the 4th, because that's the highest power we see. Once I do that, everything will simplify. So I will have the limit as x approaches infinity of, so when you distribute x to the 4th to this one, you get x cubed because it cancels with one of the x from the bottom, plus 1 over, and then on the denominator, you will get x squared. So we do the same thing here and here and here. X squared minus x. So that's what I get from the term by distributing x to the 4th, top and bottom. Now this looks much simpler to work with than what we initially had. Now I can look at the highest power on the bottom of x and then divide everything by that. And that happens to be x squared. So let's go ahead and do that. So if I do that, I have the limit as x approaches infinity. So x cubed divided by x squared, that's 1 over x, plus 1 over x squared, that's just 1 over x squared, over 1 minus 1 over x. And now I can take the limit. So I see that this will go to 0, this will go to 0, and this will also go to 0. So all of those terms involving x on the denominator goes to 0. So I am left with 0 over 1, which is simply 0. So this limit is also 0. So for this limit, we want to simplify it first before we apply the infinity rule, because it seems like if you plug in negative infinity, well, we get a statement like infinity minus infinity. So something like that, we don't really know what that means. So we can simplify it algebraically. Now think of it as this is all over 1. So I can bring up the idea of a conjugate because it involves radical. So I know the conjugate for this expression is going to be the square root of x squared plus 3 minus x. I'll take the conjugate, multiply top and bottom by that. So we have the limit as x approaches negative infinity of the square root of x squared plus 3 plus x divided by 1. And now we multiply by the conjugate. And the conjugate, we just said it's going to be the square root of x squared plus 3 minus x, top and bottom. So that gives us the following. Now, once I have multiplied by the conjugate, I simply distribute the top and simplify, and the top will become difference of two perfect squares. So you'll have x squared plus 3 minus x squared. That's what happens when you distribute this to that, and then similarly this to that. So once we have obtained that, divide everything by just what's on the bottom. That's 1 times the conjugate square root of x squared plus 3 minus x. And now you see that I can simply remove these parentheses and these will cancel out. So we're left with the limit of that function as we go to negative infinity. That's 3 over a square root of x squared plus 3 minus x. So here, if we try to use the method we used earlier, dividing every term by the highest power of x in the denominator, it would give us 0 over 0. So that doesn't seem to work. So what we're going to do is we'll try to change the variables and then take the limit. So we'll do the following. So we'll say, okay, let's introduce another variable, t. Let t approach, let t stand for x, negative x. Maybe that will work. So let t stands for negative x. So then as x approaches negative infinity, t would approach infinity. That would seem to work. So once I have done that substitution right here, I can change my limit in terms of the t variable. So this is the limit as now t approaches infinity of 3 over the square root of t squared plus 3. Now because negative x is representing t, so this is simply plus t. And now we can use the rule we mentioned earlier, divide everything by the highest power of t, in this case, in the denominator. Well, that would be this one. So the square root of t squared, that would simply be t, assuming t is positive. So that's the power we're going to divide everything by. So we have the limit of this function as t approaches infinity, 3 over t divided by square root of t squared over t squared, because t squared inside the radical is really t. That's why inside the radical it's t squared. And this is 3 over t squared all over t over t. Now simplify this. You have the limit as t approaches infinity of 3 over t over the square root of 1 plus 3 over t squared plus 1. Now if you take the limit, this will go to 0, this will go to 0. So we obtain, so this goes to 0, this goes to 0. So what we're left with is 3 over the square root of 1 plus 1 which is simply 0 over 2, that's 0.